Hello students, today we're going to look at systems of equations application problems. So we're going to be solving word problems and we're going to use systems of equations. Now there's a lot that's going to be similar to how we've solved systems of equations before. We're going to have let statements, we're going to write equations that model the situation and solve. But the difference here is that now that we can solve systems of equations, we're able to have our let statements be let the first thing be x and let the second thing be y. We don't have to write the others in terms of x because now we're capable of solving systems of equations with both x and y. Let's take a look at one example together, and then you can look at the other examples at your leisure. A bank recycles its empty printer and copier cartridges. In January, it received $40 for recycling 5 printer and 2 copier cartridges. In February, it received $19 for recycling 2 printer and 1 copier cartridge. How much is the bank paid for each printer and each copier cartridge? It doesn't actually matter if you know what a printer cartridge or a copier cartridge is. We can still go about solving this problem. Now we're going to start with our let statements. What are they asking us to find or calculate in this problem? Well, they ask how much is the bank paid for each printer cartridge and each copier cartridge. So those are going to be our let statements. Let the value, that's what they're asking us for, of a printer cartridge be x, and let the value of a copier cartridge be y. Now that we know how to solve systems of equations, we can have the let statements just be x and y. It doesn't matter which one is x and which one is y. In this sense, things have gotten a little bit easier. We don't have to decide, well, which one don't we have information about? That'll be x, and then the other one, we write it in terms of x, like 2x minus 4. None of that stuff. We've just got x and y. Couldn't be simpler. The next step, though, does get a little bit more complicated. If we have 2 variables that we need to solve for, we're not just going to have to write an equation that models the situation. We're going to have to write 2 equations that model the situation. Let's see what those equations are going to be. We're given information about January and February, so let's look at those one at a time. In January, the bank received $40 for recycling 5 printer and 2 copier cartridges. So we know that the total they got was $40. Now, how did they get that $40? Well, they recycled 5 printer cartridges and 2 copier cartridges. The value of 5 printer cartridges is going to be 5 times x, because each printer cartridge was worth x dollars, and there's 5 of them, so that's going to be 5x, plus the money they earned for recycling the copier cartridges. Well, there's 2 copier cartridges, and each one is worth y dollars, so that's going to be 2y. So we've got 5x plus 2y equals 40. That's the first equation. The second equation comes from what happened in February. They received $19 for recycling 2 printer and 1 copier cartridge. Can you figure out what the equation's going to be there? Well, 2 printer cartridges, we can represent that value as 2x, and 1 copier cartridge, we can represent that as 1y, or just y. And in total, that gave them $19. So we've got 2x plus 1y, or plus y, equals 19. Now we have a system of equations which we can solve for x and y. We have technically 3 methods that we could choose. We could choose graphing, substitution, or elimination. I'm going to be honest with you, we're never going to choose graphing. because these problems are going to be set up to be really complicated graphs. It's going to be a lot harder than it was with the problems we saw before. So really, we're going to want to use substitution or elimination. And in this case, substitution is going to work well because we can get this y on its own pretty easily. So let's isolate this y. To do that, we need to get rid of the 2x, and we can do that by subtracting 2x on both sides. The x's cancel, leaving us just with that one y, or just y, equals 19 minus 2x. And now we can use substitution. Wherever we see a y in the other equation, we can replace it with 19 minus 2x. So we've got 5x plus 2y equals 40. Let's replace that y with 19 minus 2x. And let's go through and solve. We can distribute the 2. So we've got 5x plus 2 times 19 is 38, minus 2 times 2x is 4x, and that equals 40. We can combine like terms. 5x minus 4x is just x, so we've got x plus 38 equals 40. And if we subtract 38 from both sides, that gives us x equals 2. Now that we know the value of x, we can substitute that in to the x in the other equation to get y. So we've got y equals 19 minus 2 times x, which was 2. 2 times 2 is 4, and 19 minus 4 is 15. So we've solved for x and y. Now we can go back to our let statements to figure out what the unknowns were. The value of a printer cartridge was x. We know that's 2, and this is measured in dollars. The value of a copier cartridge was y. That's 15, also in dollars. And we end by stating the conclusion. They asked, how much is the bank paid for each printer and each copier cartridge? They are paid $2 for each printer cartridge and $15 for each copier cartridge. And that is our final answer. The big difference when we're solving these word problems using systems of equations instead of just using one variable is that we're going to have our let statements be equal to x and y. In that sense, it ends up being easier. But then we're going to need 2 equations that model the situation instead of 1, and then we're going to have to solve that system of equations, which ends up being harder than in the problems we did before. However, by being able to use systems of equations and multiple variables, we are now able to solve word problems that we could not solve previously. In all the word problems we've done before, they were written very specifically so that we could write each of the let statements in terms of x. There'd always be a sentence in there like, a printer cartridge is worth $3 more than a copier cartridge. Now we can solve word problems where we don't have that direct comparison. And there's a lot of word problems out there that are set up in different ways. So even though this is a little bit more complicated than the ones we've done before, we've actually opened doors to solving problems that we could not solve before. Please take a look at some of the problems linked below the other videos, and then over the next several classes, the next several lessons, we're going to look at different types of word problems that can only be solved with systems of equations.